Hello, this is Chaudhry Mahmood Anwar. How are you all guys? Today I'll tell you how to test the Gaussian linear regression model assumption of linearity. To test this assumption, I will use this article, Data Health Assurance in Social and Behavioral Sciences Research by me. And this is a very good illustrative article if you want to understand the regression model assumptions. Here you can see all the major assumptions have been discussed in this article with illustrations and are explained in very good way to understand. I understand that most of the economics and econometrics students find this Gaussian linear regression model assumptions very difficult to assimilate, but by following this article you will find it very easy to digest. So this is the linearity assumption of Gaussian linear regression model. This assumption states that the regression model should be linear in parameters. So most of the people think linearity as the conditional expectation function of regressand is a linear function of regressors, i.e. a straight line. In fact, it's not true. So the true thing is that conditional expectation function should be a linear function of the model estimators in betas. So I'll tell you how to test linearity. So let's go to the diagnostics methodology. This is a linearity diagnostic. So there are many ways to test the linearity of your variables. For instance, some graphical ways are there, reset test is there, eta test is there, ANOVA linearity test is there, linear to nonlinear comparison and curve fitting tests are there you can use to test the linearity assumption for your regression model. I will apply the mean procedure test and then I will validate the results by using nonlinear association eta test. And in this article I have explained this. When you will run this mean procedure test, it's in fact ANOVA mean comparison test in SPSS. Here you can see that you will get variable pairs in the result of the mean procedure test, dependent variable and independent variable 1. So for this pair, the combined sum of square is 189.232, F ratio is 4.306, and significance level is 0.001. So now this combined effect has been broken into two components, linearity and non-linearity. So for linearity component, you can see the sum of square, the F ratio, and is significant at 0.001. And for non-linearity component, it's sum of square, F ratio, and it's insignificant at 0.868. So what does it mean? The non-linearity component is insignificant and linearity component is significant. Therefore, we will conclude that this pair of variables fulfill the linearity assumption of regression model. Similarly, this dependent variable and independent variable 2 is the variable pair. For combined test, it's sum of squares, F ratio, and is significant at 0.001. And the linearity component, F ratio, sum of squares, F ratio, and is significant at 0.001. And for non-linearity component, this is sum of squares, F ratio, and it's insignificant at 0.356. Therefore, we will conclude that this pair of variables is also fulfilling the regression model assumption of linearity. But if you will find the results opposite to this, for instance, linearity component is insignificant and non-linearity component is significant here, then you will conclude that your regression model or this pair of variables are not fulfilling the linear regression model assumption. Now I'll tell you how to test this assumption in SPSS. This is the first SPSS file. Its name is test.spss.sav. This is our knowledge sharing behavior variable. This is openness to experience, and this is creative self-efficacy. This is the data view and this is a variable view. Here you can see the variable view of SPSS. So this is the data view. Now I'll run the mean procedures test. Go to analyze, compare means, mean. You will enter the dependent variable. We assume that knowledge sharing behavior is dependent on openness to experience and creative self-efficacy. Okay, now click on options and click on test for linearity. Continue and click on OK. This is the output window. Similar to the table I have already explained in the research paper, you will see that for this pair of variable knowledge sharing behavior and openness to experience, the combined component, sum of squares, degree of freedom, mean square, F ratio, is significant at 0.000. The linearity component, sum of squares, degree of freedom, mean square, F ratio, is significant at 0.000. And deviation from linearity, mean non-linear component, sum of squares, degree of freedoms, mean square, F ratio, is 0.1 to 9. Therefore, we will conclude that this pair of variables in the regression model fulfill the assumption of linearity. Now you will check the second pair of variables, its knowledge sharing behavior and creative self-efficacy. See here, combined sum of squares, degree of freedoms, mean square, F ratio, and significance. It's significant at 0.000. So the linearity component is significant at 0.000, and deviation from linearity component or non-linear component is insignificant at 0.356. Therefore, you will conclude that this pair of variables in your regression model fulfills the linearity assumption of the regression model. Therefore, you will conclude that your overall regression model is fulfilling the Gaussian linear regression model assumption of linearity. Now, I'll also show you a second SPSS file. In this file, this is satisfaction, this is trust, and this is loyalty variable. We will assume that loyalty is dependent on trust and satisfaction. Go to analyze, compare means, and shift the loyalty to dependent variable and satisfaction and trust to independent variables. Click on options, click on test of linearity, continue, OK. So this is the outcome. This is the variable loyalty and satisfaction pair. You can see that combined is sum of square, degree of freedom, F ratio, and is insignificant at 0.218. Linearity component here is insignificant at 0.586, and deviation from linearity is also insignificant. Therefore, we will conclude that this variable pair is not fulfilling the linearity assumption. Now go to the second variable pair. Loyalty and trust. So here you can see that the combined effect is insignificant at 0.222. Linearity component is insignificant at 0.971, and deviation from linearity component is insignificant at 0.152. Therefore, we will conclude that this pair of variable in our regression model does not fill the linearity assumption of regression model. So this is how you can test the linearity. Now I will cross-check the results. Here I'll get back to the paper. To cross-check the results, now I will use non-linear association, eta test. So what is eta test? Eta test is a mean comparison test. It's a similar test we ran for mean procedures test. So for the first pair of variables, the correlation coefficient R is whatever we will conclude. Eta is in fact a non-linear association coefficient. Rule of thumb is the difference between correlation coefficient and non-linear coefficient determines whether the regression model fulfills the assumption of linearity or not. So I'll get back to my SPSS results. if you see here for my first file in which both pairs of regression model were significant for linearity and insignificant for non-linearity component, we had concluded that the regression model satisfies the assumption of linearity. Here when I ran the mean procedures test, you will find measure of association. Here you will see R, that is correlation coefficient between these two variables, 0.621. I'll run calculator here for ease. And eta, that is non-linear association coefficient, it's 0.756. So what you will do, you will check the difference between two coefficients. Now see what's the difference between these two coefficients. Non-linear coefficient 0.756 minus 0.621, and the answer is 0.135. So it means that the difference is not very large. Therefore, we will conclude that our pair of variable, this knowledge sharing behavior and openness to experience, fulfills the assumption of linearity. For our second variable, we will go here. Here you can see that R is 0.697 and eta is 0.746. So subtracted 0.746 minus 0.697. So the answer is 0.04. We can also conclude that our regression model fulfills the assumption of linearity because the difference between correlation coefficient of linearity and non-linear correlation coefficient is minimum. Okay, for our second model, for our second SPSS file in which our regression model had not fulfilled the assumption of linearity, we will go to that model and we will see measures of association. Here simply you can see that R is negative 0.09 and eta is 0.555. Therefore, the difference between eta and R is very large. And for second variable pair, you can see that for loyalty and trust, the R is 0.006 and eta is 0.513. Therefore, you can see that the difference between eta and R is very large. Ergo, you will conclude that this pair of variables is not fulfilling the linearity assumption of a Gaussian linear regression model. So this is very easy way I have told you to test the linearity assumption of a Gaussian linear regression model. I hope you liked this video. Thank you very much.